Welcome back, children. The next is permutations when all the objects are not distinct. So in the last two videos what we have discussed in all that the objects are all distinct. Now we have to consider the case if objects are not distinct, then how to calculate permutations. For example, that is letters repeated or digits repeated. In that case, for example, consider the word root. So here 4 letters are there. Usually how to calculate number of permutations of these 4 objects using all at a time. We can use the multiplication principle. So the first place we can fill in by any of the 4 digits. So 4. Then if repetition is not allowed, then you have to write 4 into 3, 3 ways, 2 ways, 1 way. If repetition allowed, then we write 4 into 4 into 4 into 4. This way we calculate. But here these two are same. So what we do? So look, here I wrote all the possible cases. Okay. I put first O as O1, then next as O2. So R, O1, O2, T. Then if O1 and O2 changes, then also the word is same, that is same as root. These two are same, but when we calculate permutation, if we write 4 into 3 into 2 into 1, their objects are all distinct. So O1 and O2 consider as distinct, but O1 and O2 are same. So these two same. Okay. Now this T O1 O2 are, T O2 O1 are. Two different ways we can write, but both represent the same word. Then RT O1 O2, RT O2 O1. So here 1, 1, 1, 1. Here TR O1 O2, TR O2 O1. Now O1 O2 TR, O2 O1 TR, that is 1, here 1. Okay. So using these 4 letters R, O, O, T, the normal way, the number of permutations is equal to 4 ways, 3 ways, 2 ways and 1 way. That is 4 3s are 12, 12 2s are 24 ways. But you just count how many here. These two same word. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 only. Okay. So how to write? How we get 12 since these two O's are same. So we have a theorem. The theorem says that the number of permutations of n different objects, n objects, the number of permutations of n objects where p objects are of same kind, then the number of permutations is equal to factorial n by factorial p. So in the last example, R, O, O, T, number of objects that is denoted as n, number of objects 4. There p objects are of same kind. P objects means 2 are of same kind. P objects are of same kind. The number of permutations is equal to factorial n by factorial p, that is factorial 4 by factorial 2. What is factorial 4? 24 by 2. What is 24 by 2? It is 12. Okay. Then theorem 4 is number of permutations of n objects where p1 are of same kind and p2 are of same kind, that is like that. Then pk are of same kind. Then the number of permutations is factorial n by p1 factorial into p2 factorial etc. pk factorial. That means, look this example. Find the number of permutations of the letters of the word institute. So what is the number of objects? N is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 are there. Then here T3 are there. Okay, T how many times? 3 times. I how many times? 1, 2. That is P1. P1 objects are of same kind and P2 objects are of same kind, like that. So the number of permutations, how to calculate the number of permutations? Number of permutations is equal to factorial n by P1 factorial into P2 factorial. That is 9 factorial by 3 factorial into 2 factorial. And you have to calculate that. Okay, understood the theorem? So the theorem 3 is, if number of permutations of n objects where p objects are of same kind, then number of permutations is equal to factorial n by factorial p. If the number of permutations of n objects were p1 of same kind, p2 of same kind and p3 like that, pk of same kind, then the total number of permutations, that's equal to factorial n by p1 factorial into p2 factorial into etc. Factorial is there. Okay, don't just write 2, it is factorial 2. Okay. Now we can do exercise. Find n if n minus 1 p3 is to n p4 is equal to 1 is to 9. Then what is the value of n? So n minus 1 p3 is to, we can write as by n p4 is equal to 1 by 9. What is NPR, children? NPR, number of permutations of n objects taken r at a time. It is defined as factorial n by n minus r factorial. Okay, so using that result we can write n minus 1 factorial by n minus 1 minus 3 factorial by factorial n by n minus 4 factorial. That's equal to 1 by 9, or which implies n minus 1 factorial by n minus 4 factorial. Then we can take the reciprocal, n minus 4 in the numerator by n factorial. So this cancel, equal to 1 by 9. Now how to cancel it? N minus 1 factorial and n factorial. Which is greater, n minus 1 or n? N is greater than n minus 1. So n factorial, that is denominator, we can write as n factorial is same as n minus 1 factorial into n, not n factorial, it is n. So we can cancel this, which implies 1 by n is 1 by 9. So what is n? N is equal to 9. Find r if 5pr is equal to 2. This is 2 into 6pr minus 1. So 5pr is equal to 2 into 6pr minus 1. 5pr is, by the definition, it is 5 factorial by 5 minus r factorial. Is equal to 2 into 6 factorial by 6 minus r minus 1 factorial, which implies 5 factorial by 5 minus r factorial 2 into 6 factorial. In the left side we have 5 factorial. So we can split 6 factorial as 5 factorial into 6 then only we can cancel this. Then denominator, minus of minus becomes plus. So it is 7 minus r factorial. So that implies 7 minus r we can take to the left side by 5 minus r factorial is equal to 12. Now we have to cancel this factorial. How to cancel? Which is greater, 7 minus r or 5 minus r? 7 minus r. What is the term before 7 minus r? How to find a term before that? You have to subtract 1, isn't it? So 7 minus r, the term before is 6 minus r. What is the term before 6 minus r? It is 5 minus r. Just subtract 1. 7 minus r minus 1, that is 7 minus 1 is 6. Then 6 minus r minus 1 becomes 5 minus r. Okay. So 7 minus r factorial we can write as 5 minus r factorial into 6 minus r into 7 minus r by 5 minus r factorial. So cancel. Now open the bracket. 6 7s are 42 minus 6r minus 7r plus r square is equal to 12. Or how to write a quadratic equation? R square minus 13r plus 30. Splitting the middle term. Product is 30, sum is 13 minus 13. So we can take 10 and 3, which implies r minus 10 is 0 or r minus 3 is 0. So r is equal to 10. R is equal to 10 or r is equal to 3, which we take in that NPR. What is the condition for r? R can be equal to n or less than n, not more than n. Here we have r is equal to 10 and 3. Here look, n value, here 5, here 6. So we can't take 10, isn't it? So r is equal to 3. Small value should be equal to or less than n. R is equal to 3. How many 4-digit numbers are there with no digit repeated? How many 4-digit numbers are there with no digit repeated? 4-digit numbers. How many digits are there? Digits. We can use 0 to 9. Number of digits. Equal to 10, isn't it? 0 to 9, how many digits? 1 to 9, 9 digits plus 0. So total number of digits 10. And we have 4 places, isn't it? So number of objects, that is n. Number of objects n is equal to 10. And we have to use, we can use only 4. Okay, that 4 means r. That r value is 4, but wait, here 4 places. We can't use 0 in the first place. Why? If we use 0 in the first place, then this 4-digit number, this reduces to a 3-digit number. Then that cannot be a 4-digit number. So we can't use 0 in the first place. Okay. So that is a restriction. So the first place, which is the first place? Unit place, tens place, hundreds place, thousands place. So this thousands place we can fill in how many different ways? There are total 10 objects are there, but 0 we can't use. So 9 digits, 9 ways are possible. Okay. So thousands place we can fill in by can be filled in by 9 different ways. Why 9 different ways? Since 0, we can't write 0 in the first place. We can't write 0 in the first place. So the first place we can fill in by how many different ways? In 9 different ways. Now what about the next place? Total we have 10 digits. In that 9 ways we can use in the first place. Then when we move to the second place, digits, no digit repeated. So 1 digit in the first place, whatever digit other than 0, any one of the 9 digits we can use in the first place. Then the next place, when we move to the next place, we have how many digits in our hand? Again 9 digits are there. We can use 0 in the second place and 1 digit in the first place. Okay, so again 9 digits are there. So the second place, that is hundreds place, we can fill in by 9 different ways. Then when we move to the tens place, how many digits? 8 digits are there, and in the last place 7 digits, since no digit repeated. Otherwise we can write the same. So hundreds place we can fill in by can be filled in by 9 ways. Tens place 8 ways, and units place or ones place 7 ways. So what is the total number? What is the question? How many 4-digit numbers are there? So number of 4-digit numbers satisfying this condition is equal to 9 into 9 into 8 into 7. This is by using multiplication principle. We can use the permutation notation also. So or how to use the permutation notation. Anyway, the first place there is restriction, that is we can't use 0 in the first place. So that place we can fill in by 9 ways. That you have to write as 9 itself. Now how many places remaining? 1, 2, 3 places. And how many digits we have? 9 digits. 1 digit is in the first place. So we have 9 digits. That is n is 9, and how many places we have? How many objects we have to use? That is r is equal to 3. Isn't it? 3 places. 1, 2, 3. So 9 into 9p3. That notation also you can use. 9 into 9p3. Okay. Now you calculate what is the value. So either you can use the multiplication principle or using the permutation notation. So 9 9s are 81. 81 into 56. 6. 4 5 3 6. 4 5 3 6. You can use this notation also. Okay. 9 into 9p3. What is 9p3? 9 factorial by 9 minus 3 factorial. That is 9 into 9 factorial by 6 factorial. The same answer you will get. 9 factorial can be written as 6 factorial into 7 into 8 into 9 by 6 factorial. 6 6 cancel. Then also the same digits. So there also you will get 4 5 3 6. Understood? And the next one, how many 3-digit even numbers can be made using the digits 1 2 3 4 6 7 if no digit is repeated? Here 3-digit even number. So even number, there is even number means the last place that you have to fill. You have to write even numbers only in the last place. Okay. So which are even numbers in the given digits? 2 4 6. So So unit place can be filled in by 3 different ways. Can be filled in by 3 different ways. By using any of the digits, 2, 4 or 6. Okay. Any of the digits 2 or 4 or 6. We have 3 even numbers. We can use any one in the last place. So there are 3 ways. Now moving to the next tens place. How many digits we have total? 6 digits are there. N is equal to 6 is given. Total 6 digits are given and 1 is here. Now how many digits, how many ways we can use? 5 ways we can use. Okay. So tens place we can fill in by tens place by how many ways? 5 ways. Since 1 digit is already in the units place. Now hundreds place in how many ways? Hundreds place by how many ways? No digit repeated means here 5 ways, then here when we go to the next place it is 4 ways. So 4 ways. Okay. So what is the required number? Therefore number of 3 digit numbers. Satisfying the condition, that is 3 digit even numbers. Okay, 3 digit even numbers using the given digits. Using the given digits is equal to 4 into 5 into 3, that is 60. Or can you say how to write using permutation symbol notation? Here also the last place there we can't use the permutation symbol, it is a restriction. Last place we can fill in by 3 different ways. Now we have 2 places and 5 digits. Total 6 digits are there, but 1 is already in the unit place. Now we have only 5 digits and 2 places. So here we have to write 5P2. Okay, NPR. What is 5P2? 5 factorial by 5 minus 2 factorial. That is 5 factorial by 3 factorial into 2. 3 factorial into 4 into 5 by 3 factorial into 3. Sorry, it is 3. That is also 60. Okay. Next one. How many words with or without meaning can be made from the letters of the word Monday? Assuming that no letter is repeated. If first question 4 letters are used at a time, then all letters are used at a time. All letters are used but first letter is a vowel. So the word is given Monday. 4 letters can be used. In Monday, how many letters? Total number of letters. 6 letters are there. That is number of objects is equal to 6. And how many we have to use? 4 letters. So R is equal to 4. So what is the required number? Number of words is equal to, or we can write required number of words. (6P4). Or how to write, children? 4 places and 6 letters, isn't it? So we can write 6 into 5 into 4 into 3. The first place we can fill in by 6 ways, second place 5 ways, third place 4 ways and last place 3 ways. Since we can't write, and that is repetition is not allowed. Or 6 into 5 into 4 into 3. Now calculate, or 6p4, anyway you can do. Okay, 6 5s are 30, 30 into 4, 120, 120 into 3, that is 360. Now the next is all letters are used at a time. All letters are used means number of objects 6 and R is also 6. So required number of words, both are 6. 6p6. Or how we write 6 places. First place in 6 ways, 5 ways, 4 ways, 3 ways, 2 ways, 1 way. That is same as 6p6. npn is equal to n factorial. Okay. Or it is same as 6 into 5 into 4 into 3 into 2 into 1. Any way you can use, children, either this notation or this, which is easy for you, that way you write. So what is the value? 6 5s are 30, 6 factorial is equal to 720. Now the third one is all letters are used but the first one must be a vowel. Monday, how many vowels are here? Vowels means A, E, I, O, U. Here we have O and A. 2 vowels are there. Okay. So first letter must be a vowel. So all letters we have to use, that is 6 letters we have to use, but the first letter must be a vowel. So first place we can fill in by only 2 ways. First place can be filled in by 2 different ways. 2 different ways by any of the 2 vowels O and A. So first place by 2 ways. Total we have 6 letters. So 1 is in the first place, then remaining how many letters? Then 5, then 4, 3, 2, 1. Okay. Therefore required number of words is equal to 2 into, or in permutation notation 1 2 3 4 5, 5 places and 5 objects. Okay. So it is 5p5, or that is 2 into 5 factorial, or that is same as 2 into 5 factorial is 1 into 2 into, or 5 into 4 into 3 into 2 into 1. 5 factorial means it is 120. So 120 into 2 is 240.